In Activity 9, Making a Cloud, students learn the conditions necessary for cloud formation. Students first observe a cloud form in a jar of hot water, then describe the formation of the cloud, and finally infer how clouds form in nature. You will need the following materials from the kit: Activity Sheet 9, plastic jar, and a rubber band. You will also need to provide ice cubes, plastic wrap, hot tap water, black paper, and a flashlight. To prepare for the activity, make a copy of Activity Sheet 9 for each student. You will also need hot tap water and ice cubes. To begin the activity, ask students, "What is a cloud?" Accept all reasonable responses. Explain that a cloud is a mass of very small water droplets. Then ask students, "Do you think we could make a cloud in the classroom?" How could we do it? Accept all reasonable responses. Next, fill the plastic jar about 1/3 full of hot tap water. Tell the students that you will use this setup to create a miniature cloud. Ask a student volunteer to place a square of plastic wrap loosely over the mouth of the jar and secure it with a rubber band. Then place about 4 ice cubes on top of the plastic wrap. Ask students, "What temperature is the water in the jar?" How can you tell? Students may feel the side of the jar and note that the water is warm. Explain that in this model, the water in the jar represents the surface water of lakes and oceans that are warmed by the sun. Ask students, "What is happening in the jar? What do you see just above the water?" Students should observe that the air in the jar is getting cloudy. Some of the students may note that the water is evaporating or changing to water vapor as it enters the air. Explain that the water vapor they observe is actually a miniature cloud. To see the cloud better, have a student place a piece of black construction paper behind the jar. Turn off the lights and shine a flashlight through the side of the jar. Then ask students, "How do you think this cloud formed?" To help them, encourage students to recall the evaporation experiment from Activity 7. Next, ask students, "What happens to the water vapor in the jar?" Students should answer that the water vapor rises. Then ask, "What happens to the water vapor as it rises high in the jar?" Students should realize that as the water vapor gets farther from the heat source, the water vapor begins to cool. They may also recognize that small droplets of water are forming on the underside of the plastic wrap. Encourage students to recall the condensation experiment, also from Activity 7. Remind them that the warm air can hold more water vapor than can cold air, and that a cloud consists of tiny water droplets formed when water vapor cools and condenses in the air. Next, ask students, "In the earlier condensation experiment, where did you see the condensed water? Why did it condense there?" The student should say that the water condensed on the outside of the tumbler because the ice cooled the tumbler, which cooled the air nearby. Remind them that water vapor needs a solid surface to condense on. Tell the students that the atmosphere is filled with tiny particles of dust, dirt, and smoke, and that water vapor condenses on these particles. Ask students, "How can we know that there are dust particles in the air?" Students may respond that we can see the dust when sunlight hits it, or that dust and dirt settle on cars, windows, and outdoor furniture. Distribute the students' journal envelopes to the class and give each student a copy of Activity Sheet 9. Review the directions and make sure that each student understands what to do. Then, instruct students to complete the activity sheet and review their answers. Finally, make sure that students understand the processes involved in cloud formation. To conclude the activity, throw away the ice and plastic wrap. Pour the water into the sink. Rinse the jar and return it to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.